So we will continue with the topic. చూడమ్మా పాలిమర్స్లో ఏమవుతుంది జనరల్గా ఫస్ట్ వన్ క్లాసిఫికేషన్ ఆఫ్ పాలిమర్స్. యాక్చువల్లీ వాట్ ఈస్ పాలిమర్? Polymerization. Polymerization means it is a process of converting. It is a process of converting. Process of converting a simple molecule of low molecular mass to huge molecule with higher molecular mass. హయ్యర్ మాలిక్యులర్ మాస్ అంటే ఏమవుతుందంటే జనరల్గా ఈ ప్రాసెస్లో సింపుల్ మాలిక్యూల్ హయ్యర్ మాలిక్యూల్ మార్చడానికి ఆ ప్రాసెస్ మనం ఏంటంటే పాలిమరైజేషన్ అంటాం. సో ఇన్ దట్ వన్ ద రిపీటింగ్ యూనిట్ is called polymer. The repeating unit is called monomer. And the high molecular mass compound is called polymer. సో నెక్స్ట్ వచ్చేసరికి మనకి సో టైప్స్ ఆఫ్ పాలిమర్స్ లేదా క్లాసిఫికేషన్ ఆఫ్ పాలిమర్స్ అని చెప్పొచ్చు. Classification of So in classification of polymers, what we can say? First one is based on the monomer unit. Based on monomer. So this is first one we are having based on the monomer unit. We are having homopolymer and copolymer. So homopolymer means what we can say? Homopolymer means we are having in which only one kind of monomer unit is present. Okay, type of monomer unit ఉండేది only one kind of monomer unit is present. Whereas copolymer ఎలా డిఫైన్ చేయొచ్చు అంటే in which more than one kind of polymer is present. Okay, more than one kind of polymer ఉన్నది. That is called homopolymer. Next one, second way of classification is based on source. So based on the source, so that means based on the available, we are having different types of polymers. That is what natural polymer, natural polymer. So in the natural polymer, what we are going to observe natural polymer. So in the natural polymer, uh, which are obtained naturally, uh, which are obtained naturally. సో ఎగ్జాంపుల్ ఏం చెప్పుకోవచ్చు అంటే సిల్క్, wool. సో నేచురల్ పాలిమర్స్ ఏం చెప్పుకోవచ్చు అంటే జనరల్గా విచ్ వీ కెన్ సే సిల్క్, wool, cellulose. These are all called natural polymers we can say. ఓకేనా? Next one we can say, next one we are going to discuss about the synthetic polymers. Okay, synthetic polymers. So synthetic polymers are which are man-made polymers. Okay, which are man-made polymers. Which are man-made polymers? Like examples, what we can say: rubber, PVC, polyethylene, PVC, rubber, polyethylene. These are man-made polymers. Next one, semi-synthetic polymers. Semi-synthetic polymers. So semi-synthetic polymers, what we can say. So like these are not natural and these are not synthetic polymers also. So these are obtained by, okay, these are obtained by doing some modifications, some modification in natural polymer. అంటే natural polymer ne by doing some modification, by reacting with any other compound or by doing some chemical reactions, we are going to get example vulcanized rubber. Vulcanized rubber. Vulcanized rubber. Next one, nitrocellulose, etc. So this is first way of classification. Next one, second classification is, next classification is based on synthesis. So actually these are only there in our examples. Based on synthesis, what we can say, these are two types: addition polymers, addition polymers, and condensation polymers. Addition polymers and condensation polymers. So addition polymers means what? Addition polymers. These all we will discuss in examples. Addition polymers, which are formed, which are formed by addition of polymers. Like examples, what we can say, polyethylene, polyethylene, PVC, rubber. These are all addition polymers. Next one, condensation polymers. So condensation polymers means what? So these are the polymers formed by these are the polymers formed by uh, removal of simple molecules like simple molecules like HCl, H2O, NH3, etc. Okay, that means simply between two monomer units we are removing some molecules, that is condensation. Addition means simply we are going to add on the polymer monomer units. Okay, next one, based on the structure. Based on the structure. So based on the structure, what we can have generally, we are having based on the structures, we have different types, that is linear chain polymers. So linear chain polymers ఎలా ఫామ్ అవుతుందమ్మా? Linear chain polymers means simply the monomers are joined together to form linear chains. For example, if I'm taking this is the one monomer unit, so likewise it is going to have. Okay, so these all are simple monomer units we can say. Okay, so this is one linear chain. Next one, branched chain polymers. Branched chain polymers. This branched chain polymers is also nothing but this branched chain polymers is nothing but two-dimensional polymers also we can call it as. Okay, so what we can say to monomer linear chain. Okay, so in this one what we can say to monomer linear chain. So branches are going to form. The monomer units are joined by branches. Like if I'm taking this is one monomer unit I'm taking. So likewise these are going to have branches. Okay, these are like branches we can say. Branched chain polymers are these are only. Next one, cross-linked polymers. Cross-linked polymers. Okay, cross-linked polymers. So what we can say cross-linked polymers. So in this one, Linear chain polymers, linear chain polymers joined together to form three-dimensional network type of polymers. Network type polymers. Next one, very very important, that is based on molecular forces of attraction. Molecular forces of attraction. So because of this, we are having basically three types. We are having like fibers, elastomers, and thermoplastics. We are having thermosetting plastics also. We can have. Okay, first one is elastomers. So, elastomers means what we can say. In which forces of attractions are molecular forces between polymer molecular units are molecular forces of attraction attraction is weak. So weak forces will be there. So because of these weak forces, what we can say, they can stretch it to maximum extent. So these can stretch it to maximum extent. Okay, this is what we can say. Elastomers like rubber, bionized rubber, bionized rubber. Okay. So this is what we can say. What we can say, elastomers. Next, fibers. So fibers means what we can say, fibrous. So these polymers will have strong forces of attraction, like hydrogen bonding, dipole-dipole interactions, dipole-dipole interactions. Okay. Uh, Now, for this one examples are what we can say, nylon 66, terylene, which is also called as decaron, or which is also called PET, polyethyl terephthalate. Next one, thermoplastics. So thermoplastics means what we can say, uh, in which intermolecular forces are neither weak nor strong. Okay, intermolecular forces are neither weak nor strong. Examples what we can say, PVC, polyethylene, Teflon, etc. Okay. Next one. Uh, Last one is thermosetting plastics. So in thermosetting plastics, what we can say, uh, థెర్మోసెట్టింగ్లో ఏముండదంటే these polymers have extensive cross links between monomer units uh, these become hard on heating. Example, backlight, urea formaldehyde resin. Okay, so generally the order of these polymers are, first we will get thermosetting plastics, and after that we are going to have fibers, then we are going to have thermoplastics, and lastly we are having elastomers. Okay, the order of forces of attraction between the molecules. Okay. Now, as we have discussed in this topic, we are going to discuss about mainly two polymers, I said. Okay, na? The two polymers are what? Addition polymers and condensation polymers. Okay. Now, first let me. Okay, so in this one topic, we are mainly going to discuss some examples of addition polymers and condensation polymers. Okay, in that one, first we are going to discuss about the addition polymers and their examples. Okay, addition polymers, their examples, and their uses. Okay, so under addition polymers, first one we are going to discuss about the polyethylene. Polyethylene. So generally polyethylene are two types. What we can say simply, low density polyethylene, low density polyethylene, and high density polyethylene. High density polyethylene. This we will call it as LDPE, and we are going to call it as a HDPE. Whether you take a low density polyethylene and high density polyethylene, the monomer unit is ethene only. Monomer is ethene. Ethene means this. Only for low density polyethylene and high density polyethylene, what we can use, only the conditions are going to change. For example, low density polyethylene, if I'm taking low density polyethylene, n molecules of ethane, if I'm taking at high temperature and high pressure, high temperature and high pressure, and O2 or peroxide conditions. So we are going to get polyethane. We are going to get. This is remember a symbol of polyethane. Sir, how we are getting? Simple. For example, let me take two molecules of ethane. I'm taking. And the two molecules, what we can say, first molecule will shift towards this direction, and this molecule shift towards this direction. So from these two, what we can say here, so this is will get negative charge and this will get positive charge, no? So we will get CH2 here positive charge, CH2, CH2, CH2 negative. So if one keep on going like this, what we can see here, CH2, CH2 repeated 2 times, right? Similarly, if I'm taking n times, we are going to get n times repetition will be there. Okay. Next, here the low density polyethylene uses what we can find out. Uses we can find it out as a what we can say low density polyethylene. No? Low density polyethylene we can use for packing. Next, cable insulation. Water bottles we can use this. Okay, na? Next one, second is high density polyethylene. High density polyethylene. High density polyethylene. This is also same only. N molecules of ethane we are going to take as a monomer unit. This by at low temperature and low pressure as compared to low density polyethylene. In presence of Geisler-Natta catalyst. Geisler-Natta catalyst. I will write what is catalyst. We are going to get HDPE, high density polyethylene. So here what we will use, Geisler-Natta catalyst. So Geisler-Natta catalyst what? Titanium chloride and triethyl aluminum. So what is this? Titanium chloride and triethyl aluminum combination only we are saying that Geisler-Natta catalyst. And high density polyethylene work we can use water tanks, buckets, dustbins. In this one we are going to use high density polyethylene. Next one, Next polymer is polystyrene. This is also called as styrene. So in this one, monomer unit is styrene. Monomer unit is styrene. The styrene form is this. This is also called as vinyl benzene. Okay, vinyl benzene. This is what we can say about the styrene. Okay, so how we are going to get, see. This vinyl benzene, by taking n molecules, simply just remove the double bond here and take n times. This is only styrene or polystyrene. And where we are going to use this polystyrene, like food containers, TV cabinets, TV cabinets, radio cabinets, ఇంకెక్కడ యూజ్ చేయొచ్చు అంటే ప్లాస్టిక్ కప్స్, ఓకే. దీంట్లో మనకి స్టైరన్ వీఆర్ గోయింగ్ టు యూస్. నెక్స్ట్ వన్, నెక్స్ట్ వచ్చేసరికి టెఫ్లాన్. టెఫ్లాన్ కోటెడ్ ప్యాన్స్ అంటాం కదా. టెఫ్లాన్, దిస్ is also called as polytetrafluoroethane. Polytetrafluoroethane, which is also called as PTFE, also we could call it. FE. Okay, PTFE. In polytetrafluoroethane, what we can say, monomer unit is tetrafluoroethane. Monomer is tetrafluoroethane. Tetrafluoroethane. So this tetrafluoroethane, by taking tetrafluoroethane is this CF2 double bond CF2. This is TFE, tetrafluoroethane. This, by taking n times polymers, we are going to get Teflon. We are going to get. Okay, we will get PTFE, which is also called as Teflon. So where we are going to use this? So uses as it is heat resistant. Teflon is heat resistant polymer. Heat resistant polymer. So because of this, what we can use, gaskets, non-sticky surface, non-sticky surface utensils, and insulators we can use. and then insulators we can use. ఓకే. నెక్స్ట్ వచ్చేది ఏంటంటే నెక్స్ట్ పాలిమర్ ఇస్ పీవీసీ, పాలీవినైల్ క్లోరైడ్. పాలీవినైల్ క్లోరైడ్. ఓకే. పీవీసీ. For this one, monomer unit is what? Vinyl chloride. Vinyl chloride. And the structure is this. Vinyl chloride. So this vinyl chloride, by taking n times, we are going to get polyvinyl chloride. Polyvinyl chloride we are going to get. So it is what we can say, it is thermoplastic. Thermoplastic. Electrical raincoats. Electrical insulators. Raincoats lo. Next what we can say, handbags. Plastic doors. Okay, in these cases we are going to use PVC. Next one, so these are the basic polymers. Okay, next one we are going to get last polymer is polyacrylonitrile. Polyacrylonitrile. అర్థమవుతుంది కదా స్టూడెంట్స్? Polyacrylonitrile, that is PAN. Okay, polyacrylonitrile, PAN. So in this one, the monomer unit is acrylonitrile. Acrylonitrile. That is this. This acrylonitrile, by doing polymerization, we are going to get polyacrylonitrile. Okay, this is what we can say, PAN we can say. Polyacrylonitrile we can say this. So generally what we are going to use here, carpets, ఇంకెక్కడ యూజ్ చేయొచ్చు అంటే బ్లాంకెట్స్, క్లోత్స్లో యూజ్ చేస్తాం. క్లోత్స్, blankets, carpets lo we can use. Okay, this is what we can say about the additional polymers. Okay, next concept వచ్చేసరికి మనకి ఏమొస్తుందంటే రబ్బర్. Okay, rubber and vulcanization rubber. Okay, rubber and vulcanization of rubber. Generally, rubber, what we can say, okay, in rubber also we are having two types. Okay, rubber. So in the rubber also what we can say, we are having two types, that is natural rubber, natural rubber and synthetic rubbers. Synthetic rubber. Generally, rubber, what we can say, uh, obtained from rubber latex. ठीक है. Natural rubber. Natural rubber is obtained from, how we can say, obtained from rubber trees. Rubber trees in the form of rubber latex. ठीक है, rubber latex, which is like a milky type of nature. It will be the rubber latex mass. Rubber latex mass. So it is coagulated with generally rubber latex is coagulated with acetic acid or formic acid. Okay, acetic acid or formic acid. So as we have seen, in the natural rubber, monomer is cis isoprene units is there. Natural rubber monomer is cis isoprene. Isoprene. So isoprene is 2-methyl 1,3 butadiene. So isoprene is also called as 2-methyl 1,3 butadiene. So this is known as isoprene. So these isoprene units are joined by 1, 2, 3. Okay, so isoprene units are joined in. So here what we can say, natural isoprene units are joined by in cis manner. Isoprene units are joined in cis manner. Okay, and next one is one more natural isomer is there, that is gutta perca. So in this one, what we can say, in this type polymer, in this type rubber, what we can say, isoprene units are joined in ట్రాన్స్ మేనర్. గుర్తుపెట్టుకోవాలి మీరంతా కూడా ఇది. సో స్ట్రెస్ మేనర్, ట్రాన్స్ మేనర్. So that is what we can say about the isoprene units we can say. For example, 2-methyl 1,3-butadiene, if I am taking this, by polymerization we need to add trans isomer, right? And trans isomer, if we are getting this, Okay, this is trans isomer. Trans isoprene. If I'm taking cis isoprene, how we will write here? Same way. Like see here, that CH2 CH2 units are there, no? That will be in same side. It will be there. That is called cis isomer. Okay, this is cis isoprene. So cis isoprene is nothing but natural rubber, whereas trans isomer is nothing but what we can say, gutta perca we can say. Okay, students. So this is about the topic for today, right? And in next class we will continue rubber, vulcanization of rubber and condensation polymers we can do. Okay. Thank you, students. All of you. Good night. Thank you.